question number 4. It says the number of particles crossing per unit area perpendicular to x-axis in unit time is given by this equation. Okay, so अब हम देखेंगे they have given like n1 and n2 are the number of particles per unit volume for the value of x1 and x2 respectively. The dimensions of diffusion constant d, that's what they are asking. Okay, perfect. So let's start solving this question. N is equal to minus d n2 minus n1 over x2 minus x1. That's what they have given. Let me put this as equation number 1. Okay, perfect. So let us see that what they have given, information regarding this capital N. तो यहाँ पे clearly इन्होंने mention कर रखा है this capital N is nothing but the number of particles crossing per unit area perpendicular to x-axis in unit time. This unit time, this we need to consider. So okay, let me write this N. They are saying number of particles per unit area, right, per unit time. So here I can write time as well, right? So if we want to write the dimensions of this capital N, so what do we need to do? Simply we need to write, see, number of particles, it is number, so number, they do not have any dimension, so I'm going to put N. Area, I'm going to put A, and time I'm going to put T, right? अब देखिएगा area, what is the dimension of area? So you will write L square, and for time it is T just. So it is going to be L minus 2 T minus 1. So this is nothing but the dimensional equation for capital N. L minus 2 T minus 1. Okay, perfect. Now let's move to the next one, like N1 and N2. What they have given? Let's see what the information they have given about N1 and N2. Both of them are the same thing. So let us see what they have given. So N1 and N2, they have mentioned that it is number of particles per unit volume, right? This is nothing but number of particles per unit volume. So in the same way, I'm going to write the dimensions of N1 and N2, right? Okay, so N1 and N2, this is number of particles. So number of particles, I'm writing 1 for that. Per unit volume, so I'm writing 3 over here. So as we know that the dimensions of volume is what? LQ. Send this LQ up, so you'll be getting dimensions of N1 and N2. It is going to be L raised to the power minus 3. Okay, perfect. Now, so we are left with just this x2 and x1. So what they have given about x2 and x1? So x1 and x2, this is simply the distance. So x1 and x2, it is going to be, as it is representing distance or displacement, so it is going to be L. Okay, perfect. Now let us substitute all these dimensional formulas in equation form. So on substituting dimensions of capital N, a small n1, comma a small n2, x1 and x2 in equation 1. Okay, so we will be getting, at the place of n, we are going to write L raised to the power minus 2, 3 raised to the power minus 1, L raised to the power minus 2, 3 raised to the power minus 1. And here this negative sign, actually in dimensions, negative sign and positive sign does not make any sense. So here simply I'm going to write T. It does not have any significance actually, this minus sign. Okay, so N2 and N1, आप देखिए N2 and N1 है क्या जी? It is going to be L raised to the power minus 3, and here also I'm going to write L raised to the power minus 3. What is this x1 and x2? They are representing just length, so L minus 3, right? Okay, fine. So L raised to the power minus 3 minus L raised to the power minus 3. Do not say it is going to be 0. No, it is dimensions. The way we had studied, L minus L is equal to L and L plus L is equal to L. Similarly, can't we write L raised to the power minus 3 minus L raised to the power minus 3 as just L raised to the power minus 3, and L minus L is equal to L. So L raised to the power minus 2, 3 raised to the power minus 2. Okay, send this L up. So this will become what? This will become D L raised to the power minus 4. And here you have L raised to the power minus 2, 3 raised to the power minus 1. So finally, you are going to get D is equal to, send this L raised to the power minus 4 down. So it will become L raised to the power minus 2, 3 raised to the power minus 1 divided by L raised to the power minus 4. And you will be getting L raised to the power 2, T raised to the power minus 1. So we are getting the dimensions of D as, let me write over here, we are getting the dimensions of D as L raised to the power 2 and T raised to the power minus 1. This can be also written as M0 L raised to the power 2 and T raised to the power minus 1. So let us check in the options. This is our answer actually. So let us check in the options which option is the correct one. So you will say that option number M raised to the power 0, L raised to the power 2, T raised to the power minus 1. Option D is the right one. Okay, perfect. So that's the end of question number 4. Let's move on to the next question.